while we were talking about the changes between these eons, you mentioned also plate tectonics play a huge role. So let's go there. What are plate tectonics? And then what causes their movement?
Okay. Yes. Plate tectonics is based on an observation, which is that features at the surface of the Earth move through time. This was first argued as a concept called continental drift back, almost 100 years ago. And people didn't like it because nobody could see how continents could move through this oceanic crust made of volcanic rocks. And so it was pretty much dismissed. And then really beginning with observations by submarines during World War II, if we found out there was this big mountain chain in the middle of the Atlantic Ocean. And it was later found that that was actually creating new crust, and the crust was spreading out. And that was pushing the continents apart. And that's how continental drift was born. So there are about 7 or 8 major plates on our planet and some smaller ones. And there are places where new oceanic crust is forming, and that's pushing continents apart. Because we live on a sphere, that means there are places where the oceans are getting smaller and continents are coming closer together. What will happen is that the oceanic crust can actually get pushed under continents, and that forms mountains. The Andes, the Rockies, those are mountains that form when continents move over so-called subducting crust, and that then you also get mountains form when 2 continents collide, when India crashes into South Asia, building up the Himalaya and things like this. So continental drift has really given us a new, within my adult lifetime really, a new understanding of the physical features at the Earth's surface. And that has been wedded to increasingly refined work on Earth's mantle underneath the crust, where it's very clear that the mantle on geologic timescales actually circulates the materials of it. And it's that mantle circulation of warm material rising, cooler material going back down toward the bottom of the mantle again that actually drives what we see at the surface. And so plate tectonics, you're absolutely right, is a defining feature of the Earth. And I think when people start talking about how is it that life has persisted for so long on this planet, there's a place at the table for plate tectonics.
Such a massive component of the evolution of life. So the way I understand, so warm mantle rises up at the ridges, and that becomes new crust. And that's happening, let's say, in the Atlantic Ocean. So it's expanding year by year, very, very slowly. And then at the Pacific Ocean side, there are these subduction zones that then move down, and they, I guess, melt away as well.
Right.
So that's what's causing the volcanoes in those regions?
That's exactly right. People often talk about the ring of fire because there are volcanoes that arc all the way along, line almost the whole Pacific. And that is because crust is subducting, it's melting, and that fuels the volcanoes. Yeah.
Is that also what causes the earthquakes?
It's one of the causes of earthquakes, yeah. And again, earthquakes, by definition, reflect tectonics. Commonly, that is associated with plate tectonics. There are other things that go on. So, for example, in the United States, I think about the strongest earthquake that we have evidence of took place in the past near where St. Louis is today. That's not on a plate boundary. That's in the middle of a plate. And people are just now starting to come to a more sophisticated understanding of materials moving through the mantle that might help explain why. It's easy to explain earthquakes in Los Angeles, which is right on a plate boundary. You need things besides plate tectonics 101 to explain what went on in the past in St. Louis and other places like this. But, the good news is that again, within my lifetime, our understanding of how the earth works has been revolutionized. It's amazing.
So what happens when there's an earthquake? What is the science behind it?
Okay, well, you have a fault, which is just where two rock masses come together. And in many cases, like in Los Angeles, the one side is moving in one direction, the other side is trying to move in the other direction. And they get locked together because of friction. And once you build up the force to overcome friction, you'll often have it give in a minute. And it's that sudden release of the friction that was holding them together that causes the movement, and that's your earthquake. And so there are various geometric variants on that, but it's largely just the differential movement of two pieces of crust that are adjacent to each other.
So the picture that I have in mind is, in a way, it's like a spring that's being loaded, and it could either be released to a small extent, that would be a smaller earthquake. Yeah. But if it's held for a long time, and if you haven't had an earthquake for a long time, that would be a massive release, and that would be a big earthquake.
That's absolutely right. And that's why people like me, when I see a small earthquake in California, I'm happy, because it's doing exactly what you just said. And when things have been quiet too long, that's when you begin to worry. And we know that, I'm not an expert on this globally, but along the West Coast of the United States and Canada, there are certainly, the expectation that fairly large earthquakes will happen at least every several hundred years. So that is just, on any time scale of humanity that we can think of, earthquakes are simply part of the world you live in out there.